Hello, and welcome to this video on using differentiation to find the equations of tangents and normals. As we know from GCSE, a tangent is a straight line which meets a curve at a single point. So, look at this problem. Find the equation of the tangent to the curve y equals x squared when x is 3. We would like to use the equation y minus y1 equals mx minus x1 for the tangent, since that's a straight line equation. And therefore we need to know a point which will have coordinates x1, y1, and the gradient of the tangent, which is m. So taking our curve of y equals x squared, the gradient function dy by dx is equal to 2x, from which the gradient of x equals 3 is going to be 2 times 3, which is 6. The y value will be x squared, so that will be 3 squared, which is 9. So we have a gradient of 6, we have y is 9, we know that x is 3. So substituting those into the equation, we get y minus 9 is equal to 6 brackets x minus 3. And we might need to rearrange that and put it in the form y equals mx plus c or some other form, but that's the answer. If instead we were asked to find the equation of the normal to the curve y equals x squared when x equals 3, well, it's still the same point, which is 3, 9, but the normal, which you may or may not know, the normal to a curve is the line perpendicular to the tangent. So in order to work that out, we need to find the gradient, which is perpendicular, in this case to 6. So the gradient will be negative a sixth. So our equation is y minus 9 equals negative a sixth of x minus 3. And again, we might have to multiply that out, rearrange it perhaps. Here is our first worked example. Find the equation of the tangent to the curve y equals 4x squared minus 2x minus 17 at the point negative 2, 3. So we already know x and y at this particular point, but we don't know the gradient. So differentiating it, dy by dx is equal to 8x minus 2. So the gradient at that point, where x is negative 2, is 8 times negative 2, take away 2, which is negative 18. And then we can substitute straight into the formula. So y minus 3 is equal to negative 18 brackets x take away negative 2, which we could rewrite as x plus 2 if we wished. Now, we haven't been asked to write in a particular form, but I'm going to expand the brackets. So y minus 3 is equal to negative 18x minus 36, from which, if we write it in the form y equals mx plus c, we get y equals negative 18x minus 33. Another worked example on tangents. Find the equation of the tangent to the curve y equals 6x root x minus 8 over x at the point where x is equal to 4. So first of all, I've rewritten it as 6x to the power of 3 over 2 minus 8x to the negative 1 before differentiating it. So dy by dx is equal to 9x to the half plus 8x to the minus 2, which we could rewrite if we wanted as 9 root x plus 8 over x squared. The gradient at the point where x is 4 means substituting 4 in for x, so 9 root 4, which is 18, plus 8 over 4 squared, which is a half, so 18 plus a half is 37 over 2 as an improper fraction. And then the y value, we weren't given that, but again x is 4, so we could substitute that into y equals 6, lots of 4 root 4 minus 8 over 4. 4 root 4 is the same as 4 times 2, 4 times 2 times 6 is 48, 8 over 4 is 2. So y equals 48 to take away 2, which is 46. Substituting into our equation, y minus 46 equals 37 over 2 times x minus 4. Again, we could leave it in that form, but in this case, I've rewritten it in the form ay equals bx plus c. I've doubled everything, so I get 2y minus 92 on the left, and on the right-hand side, we're just getting rid of the 2 and expanding the brackets. So 37x minus 148. And then if I add 92 to both sides, I get 2y equals 37x minus 56. For our next worked example, we're looking at the equation of a normal. Find the equation of the normal to the curve y equals half x squared root x minus 7x when x is equal to 4. So again, to start off, I've rewritten it in index form. So y equals to half x to the 5 over 2 minus 7x. And when we differentiate that, we get 5 quarters x to the power of 3 over 2 minus 7. The gradient of the tangent will be what you get for dy by dx when you substitute 4 into it, which is 3. But we need the normal gradient, which is therefore going to be negative a third. the value of y, substituting 4 into the expression for y gives us half of 4 squared root 4 minus 7 fourths, which is equal to negative 12. And then substituting into our formula, y take away negative 12 is equal to negative a third x minus 4. Y take away negative 12 is the same as y plus 12. So I've multiplied by 3 to get 3y plus 36, and then minus x plus 4 on the right. And I've just decided to make the right-hand side 0. So I've added the x, I've taken away 4, and I've got x plus 3y plus 32 is 0. You will normally be asked what form they want you to write your final answer in. For our next worked example, we're told the normal to the curve y equals negative 11 plus 12x minus x squared at the point where x equals 5 meets the x-axis at A and the y-axis at B. Find the area of the triangle OAB where O is the origin. So our task is to find the positions of A and B, and since one's on the x-axis and one's on the y-axis and O is the origin and the axes are perpendicular, it's a right angled triangle as we can see in the diagram. The first thing I decided to do, even though it's not strictly necessary, was to sketch the quadratic curve. So I factorised out minus 1, factorised it into 2 pairs of brackets, and I got that it crosses the x-axis at 1 and 11, hence the graph. And it's a negative quadratic, so we know it's that way up. So in terms of the problem, first of all, I want to differentiate it to find the gradient function, which is 12 minus 2x. So when x is 5, the gradient of the tangent would be 12 take away 2 5s, which is 2. But we're interested in the normal, which has a gradient of negative a half. The value of y when x is 5, I can find by substituting 5 into the expression for y, for which I get 24. And then substituting that into our y minus y1 equals mx minus x1 equation. And rearranging, I get the straight line equation x plus 2y is equal to 53. From which I can find A by substituting y equals 0. So that gives me that x equals 53. And I can find B by putting x equals 0, which gives me that y is equal to 53 over 2. So the area of the triangle, half base times height, the base is 53, the height is 53 over 2. 53 squared divided by 2 squared is 2,809 over 4. And for our final worked example, we're asked to find the coordinates of the point of intersection of the normals to the curve y equals 10 plus 8x minus x squared, where y equals 25. So the first thing we want to do is to find out where those two normals are, what points they're at. So putting 10 plus 8x minus x squared equal 25, I solve the quadratic equation. That gives me that x equals 3 or 5. I already know they're on the line y equals 25. So the coordinates of the points are 3, 25 and 5, 25. Next, I'm looking for the equations of the normals. So first of all, I do dy by dx, which is 8 minus 2x. Putting in our values of 3 and 5 for x, that tells us the gradients of the tangents are 2 and negative 2, from which the gradients of the normals are negative a half and plus a half. I've then substituted our coordinates and our gradients into our y minus y1 formula. And then when I put the y values equal to each other to solve the equation, I find out that x is 4. And then I can substitute x is 4 back into one of those equations to work out that y is 49 over 2. And hence our normals intersect at the point 4, 49 over 2. Thank you very much.